Hello, ladies and gentlemen. We're going to continue our study of projectiles. And as you see on the screen, there are four different kinds of projectiles. Projectiles that are dropped, projectiles that are launched straight up and come straight back down, projectiles that are launched straight out and fall, or projectiles that are launched at an angle and move upward and outward at the same time. The variables that affect the trajectory of a projectile are determined by a number of different things, but in our class we're going to assume that air resistance is negligible. So in that case, the cross-sectional area, the air resistance, and those two variables won't make any difference since we assume air resistance is negligible. We know that in no case does the mass of the projectile have to do with its rate of descent. So none of these are variables that affect the trajectory of a projectile for our course. The things that will affect the trajectory of our projectiles will be the original launch angle and the original launch velocity. Those two variables ultimately affect launch height and the time in the air. As stated before, projectiles move both up and down and side to side potentially. Up and down motion will term as vertical motion. Side to side motion will term as horizontal motion. We're going to start our study with projectiles that are dropped or projectiles that are launched straight up. Those projectiles only change position vertically. So as we begin, we'll only be dealing with projectiles where we have a change in the up and down position and velocity. We won't have any horizontal information to consider. So in that case, for dropped projectiles or projectiles that are launched straight up, the only thing affecting their motion is the acceleration of gravity, and we will only have changes in the vertical direction. These are our projectile equations. Take a deep breath. It's not as bad as it looks. For our initial study, we are going to start with those projectiles that are dropped or launched straight up. So immediately, we won't be using these horizontal motion equations. We'll only be using these listed on this side. Now let's talk a little bit about what the variables mean and make it not quite so scary looking. You know that a y determines vertical position. So if we talk about a y position, that's an up and down position. Since projectiles will change their up and down position, we're going to have some subscripts to acknowledge that. So this yi means y initial, so that's starting position for y, and yf means y final, so that would be ending position for y. Then a vertical change in position or a distance is delta y, and that's given in this equation down here at the bottom. It's the only place you'll see the delta y show up. Then for vertical velocity, that's vy. That shouldn't be too surprising. And since velocity will change, then we have to have a further subscript on v sub y. So we'll use a vyi for a starting velocity, with I meaning standing for initial. So vyi means the starting velocity, and that starting velocity variable appears in all three of these equations. Then the ending velocity, vyf, appears in these two equations. Vertical acceleration is due to gravity, so we're going to be easy on ourselves and use just a rounded 10 rather than 9.8 for the calculations that we do for this unit. So we're going to use 10 meters per second down for the acceleration of gravity. Typically we will call this a negative number because we'll call down negative. I'm going to go ahead and just read through these equations so you can hear how they sound when we describe them. This first equation is the final vertical position of an object is equal to the starting vertical position of the object plus the starting vertical velocity of the object times the time plus 1/2 times the acceleration of gravity times the time squared. The next equation is the vertical velocity in the y direction final, so the ending vertical velocity, is equal to the starting vertical velocity plus the acceleration of gravity times the time. Then this last equation is the final velocity in the y direction squared is equal to the starting velocity in the y direction squared plus 2 times the acceleration of gravity times the change in position vertically. That's not so bad. Now, in the next video, you'll have a chance to try this and see that they're not nearly as scary as they seem.